Hello, in this video we're going to cover trigonometric ratios. And we're going to go through quite a few exercises. We're going to kind of start with just the basics of what trigonometry is, and then we'll get all the way into some real life applications. So trigonometry is really triangles, the measurement of different triangles, and it's specifically with these trigonometric ratios to right triangles. So we're going to kind of go through a couple of these. Okay. When will I ever use this? I get that question from time to time, and you want to go, Well, I thought, as a person who's very afraid of heights, what I want to know is how far above the ocean I am if I'm parasailing. Okay, so if I'm parasailing, of course, we have a rope that goes out, but I want to know what the distance is between me and the ocean. We'll get to that a little bit later. All right. So again, trigonometry is triangles, but specifically right triangles. And we know it's a right triangle because of this. You've got a square right here. And when there's a square here, that indicates this is a right triangle, meaning this angle right here is 90 degrees. Okay, and this is just a measurement, right? Sometimes you use x. This is theta, so we're going to use theta on this one, and we'll talk about a little bit about what that is. But on any right triangle, you're always going to have a hypotenuse. And the hypotenuse is always the longest side. Okay, and then with the hypotenuse, you have what we call an adjacent side. And when we think of the word adjacent, this is typically right next to, okay? A neighbor, you're adjacent to your neighbor. You're right next to it, okay? And it's right next to it in relation to whatever this angle is. Again, this is theta here. And so the only other side that we have over here, we refer to as the opposite side. It's on the opposite side of the triangle. All right, so let's kind of look at another one. This is, if you look at it, it's almost identical triangle. The only difference is I moved our measurement angle, our theta. So now that's up top. So the hypotenuse is still going to stay the same. It's always the longest side. That won't change. But my adjacent side now will change. Instead of being the one on the very bottom, that's not adjacent. That's not next to this theta. So my adjacent side would be right here next to it. And then, of course, that would make, by default, the other one the opposite side. All right. So there are three different types of ratios that we need to learn. We've got the sine ratio, cosine, and tangent. Of course, we write these in like a little code, if you will. We refer to it as sine, S-I-N, okay? This is not sin. There is no sinning in mathematics, right? It's just sine. And sine is the opposite side divided by the hypotenuse side. Okay, and then cosine, we refer to cosine as just COS, and that is the adjacent side divided by the hypotenuse. And so that one is CAH is how we shorten that one even further. And then finally we have the tangent. Tangent is the opposite over the adjacent side. Okay, so there are some people that chant this. People who are really, really big into mathematics are going to go, okay, it's time for SOHCAHTOA. And then they get up and do a little dance, SOHCAHTOA, SOHCAHTOA. Anyway, we won't do that. We won't make you do that right now. But that is something some people do. Not me, but some people. All right. So on this one, we're asked to find the sine value of x. And x is going to be this angle right here, okay? So the sine of x, let's bring in what we know. We know that the sine is the opposite side divided by the hypotenuse. So I want you to look at this one and see if you can identify what the hypotenuse is and what the opposite side is. Of course, we know the hypotenuse is our longest side. The adjacent side is one right next to it. And then, of course, the opposite is the furthest away from it, okay? So the opposite side divided by the hypotenuse. So we have 4 in this case is our opposite side, and 7 is our hypotenuse. I could take the same angle, and I could ask you to find the cosine of x. So when you're finding the cosine of x, you're going to take the adjacent side divided by the hypotenuse. So in this case, it would be 2 divided by 7. All right. And then finally, we can find the tangent of x. And tangent is the opposite side divided by the adjacent side. So in this case, it would be 4 divided by 2 or 2. We do reduce this. This is a fraction, so if it can be reduced, we will reduce these. All right. Let's get you some practice on this. Now, you know I'm big on practice. What I'd like you to do right now is I'd like you to pause the video. Then I'd like you to work this one out on your paper. And then when you're ready to check your answer, come back and push play. Okay, let's see how you did. Hopefully you remember that the sine is the opposite divided by the hypotenuse. And of course, the tangent would have been the opposite side divided by the adjacent side. And you notice on this one, I switched angles on you. The first one was angle X, and the second one was angle Z here. So you just gotta kind of pay attention to that just a little bit. All right, I want you to get a little more practice. So push pause on the video now. After you've obtained your answer, come back and push play. Okay, check your answers here. Again, I changed the angle on both of these for you. You notice that the sine of A is equivalent, is the same as the cosine of C, because all I did really is just flip the sides, flip the angles. So anyway, sine and cosine are not the same. However, whenever I switch the angles like this, they can end up being the same answer. All right, push pause on the video now, and then once you work it out, come back and push play. Okay, check your answers here. Hopefully you're starting to kind of get into a rhythm a little bit there, feeling a little more comfortable with it. So, all right. Now, in addition to those three, we've got sine, cosine, and tangent. We also have these other three. CSC is cosecant, and then we've got secant, and we've got cotangent. Cotangent's very easy because it sounds just like tangent, right? And the big thing with these ratios is they are the reciprocal of their previous one. So cotangent is the reciprocal of tangent. Okay, so we'll get into that. We'll kind of apply that. You'll start to see it a little bit. Cosecant is the reciprocal of sine. So let's kind of do that just a little bit. So if sine is opposite over hypotenuse, then cosecant should be hypotenuse divided by opposite. So again, all we do is we flip those numbers, okay? The secant is the reciprocal of cosine. So this means we're going to go hypotenuse divided by adjacent. And cotangent, that's an easy one because we know it's associated with tangent, is the adjacent divided by the hypotenuse. And so the cotangent's very easy. These two get a little bit slipped up here because cosecant, this one starts with an S. So sometimes you want to associate with this, but do not. That is not correct. Cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. Okay, now let's kind of take a look at this. I want you to find the tangent of M. So we're down here at M, and remember that tangent is the opposite side divided by the adjacent side. Here we go. Now the cotangent then would be the exact opposite, right? Instead of 15 over 8, we're going to go 8 over 15. Okay, and I got a little sloppy here. This should be a square, but you get the point. This one is a right triangle. All right. So now let's kind of look at this one here. We've got sine, cosine, and tangent. I'd like you to pause the video and at least find those, the sine, the cosine, and the tangent on this one. And then once you do that, come back and push play, and then we'll kind of walk through the rest of them together. Okay, hopefully you found these were your accurate answers. Now let's kind of go through these. If we're looking for the cosecant, remember, is the reciprocal of sine. So instead of 4/5, it's going to be 5/4. The secant would be the reciprocal of cosine. So instead of 3/5, it's going to be 5/3. And finally, cotangent, and all we're going to do is take the reciprocal of tangent, which instead of 4/3 would be 3/4. Okay, and that's it. These are all of the values. So sometimes on your homework, you're going to be asked to find the trigonometric ratios, all of them. So there are 6. Those are the 6 that we're looking for here. Okay. All right, now I want you to pause the video right now, and you're going to find all 6 trigonometric ratios. Okay, so push pause on the video now. After you've obtained the answer, come back and push play. Okay, check your answers. Those are quite a few answers. Now, you notice on the second one that this one can be reduced. So remember, if it can be reduced, it must be reduced. And it's just like a normal fraction, how we reduce it. Okay, this one gets to be just a little bit, it's not tricky. It's been a while since we've done it. Okay, so on this one, we're using Pythagorean's theorem to find the missing sign. Remember, Pythagorean's theorem is a squared plus b squared equals c squared. Okay, well, c squared is your hypotenuse. So your one side and your other side squared, when you add those two together, is equal to your hypotenuse squared. So let's kind of go through this number 1 together. All right, number 1 together, here we go. So we know a squared and we know b squared, right? 4 and 3. So I'm just going to plug in 4 for a and 3 for b. Excuse me, 3 for a, 4 for b, sorry. And it doesn't matter because it's addition, so it doesn't matter what order it's in. So 3 squared is 9, 4 squared is 16. So we have 9 plus 16 equals c squared. So 9 plus 16 is 25. 25 equals c squared. C is going to equal plus or minus 5. Now on this one I only wrote that it's positive 5, and the reason why I did that, mathematically speaking, c would be positive or negative. But because we're dealing with solely measurements, you can't have a negative 5 inches. It doesn't work. Okay, you either have 5 inches or you don't. That's it. So on this one, it will always end up being the positive on this. So C is going to be 5. Okay, now let's go through the bottom one. Okay, now if, same thing here, only on this one we know what the hypotenuse is and only one of the sides. So I can't go a squared plus b squared. I know a squared or I know b squared. It could be either one. And I know c squared, but I got to find the opposite or the other side. All right, so let's kind of just go through this. We're just going to plug in what we know. We know 6, we're going to plug in for a, so 6 squared plus b squared equals 8 squared. We know 6 squared is 36, a squared is 64, okay? So now I subtract 36 from both sides, and I'm just solving this one, just try to find out what b is. I end up with b squared equals 28, so b is equal to the square root of 28. Now the square root of 28 can be reduced, and again, anytime it can be reduced, we reduce it. So this is 2 radical 7, right? It has a 4 on the inside of 4 times 7, and the 4 is really a 2 times 2. So I've got my twins there and I can pull those out. And that would equal 2 radical 7. So this missing side on this one is 2 radical 7. Okay, now we're going to take that knowledge that we've got for the Pythagorean theorem as well as the trigonometric ratios, and we're going to combine it all in together. All right, so we've got this one here. We're asked to find essentially these trigonometric ratios, right? All these values, sine, cosine, tangent, cosecant, secant, and cotangent. Well, it's kind of hard to do that unless I know all of the sides of the triangle. So my very first thing that I'm going to do is I'm going to find and identify all the sides. In order to do that, what I'm going to use is Pythagorean's theorem. That's what we just did. Okay, so I know the 2 sides, but I don't know the hypotenuse. So I know a and b. So I'm going to plug 5 and 12 in for a and b. 5 squared is 25, 12 squared is 144. So now I've got 25 plus 144 is going to equal 169. So C is equal to 13, right? Square root of 169 is 13. Okay, so now I've identified that missing side. And now that I have that missing side, the rest of it's a piece of cake. You've been doing those for a little while now in this video. So what I want you to do right now is I want you to pause the video, and then I want you to fill out all 6 of those ratios. And then whenever you identify the answer, come back and push play. Okay. Hopefully you got all those as your answer. Remember that these second set here, if you will, are all the reciprocals of this first set. All right, so now I'd like you to start this one and work all the way through it. Okay, before we do that, I forgot about rationalizing the denominator. So let's look at this, and it's been a little while since we've covered this. When we rationalize the denominator, what that means is we can't have a radical on the bottom. Okay, so we've got to get that radical from the bottom and try to move that to the top. Okay, so how we do that is whatever's on the bottom that's troubling us, this radical 10, right? We multiply top and bottom by the square root of 10. Okay, now we're not changing anything because when you multiply it by square root of 10 over square root of 10, that's just 1. We're not changing the value at all. So now we do 3 times the square root of 10 all over the square root of 100. And the square root of 100 is 10. So that got rid of our square root. Okay, well, let's do the second one here. We're going to multiply top and bottom by square root of 6. This would be 2 square root of 6 over 36, square root of 36, excuse me. And the square root of 36 is 6. Okay, so now we end up with 2 square root of 6 all over 6. Now, this is a fraction that can be reduced, right? This 2 and this 6 can be reduced down to 1/3, which is really square root of 6 over 3, right? 1 times the square root of 6 over 3. We wouldn't write the 1 in front of it, so it'd just be square root of 6 over 3. Okay, now you're going to get some opportunity here. But before we do, let's. I want to kind of go through this one with you, and then I'll turn you loose on some, give you some practice. All right, so on this one, again, the very first thing we need to do is we need to identify what that missing side is. In this case, it's the hypotenuse. So let's use Pythagorean's theorem to identify that one. Okay, so Pythagorean's theorem, here we go. We know a and b, they're both 1s. That makes it easy. 1 squared plus 1 squared equals c squared. Well, that's good. 1 squared is 1. So 1 plus 1 equals c squared. So now we have 2. 2 equals c squared, which means c is equal to the square root of 2. Okay, no big deal. We got the square root of 2 in there. We're feeling pretty good about ourselves. All right, now we're just going to kind of fill this out. Now, sine, remember, is the opposite side divided by the hypotenuse. Okay, this is where it gets a little bit tricky. So I've got 1 over square root of 2. If you've got that so far, you're feeling pretty good. The problem is we can't have that square root of 2 on the bottom. So now I need to multiply top and bottom by the square root of 2. All right, so I do that, and then I end up with square root of 2 all over 2. All right, now we're going to do cosine. Cosine is the adjacent side divided by the hypotenuse. So again, it's the same exact one on this particular problem. It's the same one as sine. So that makes it kind of easy because then you know it's going to end up being the square root of 2 over 2. Tangent on this one is super easy, 1 over 1, which is just 1. Okay, cosecant. Now, for the cosecant one, it's the reciprocal, right, of sine. And so the reciprocal of sine is 1 over square root of 2. So the reciprocal of that would be the square root of 2 over 1. And the square root of 2 over 1 is just the square root of 2. Okay, now for cosine, just like sine and cosine were the same, cosecant and secant are going to be the same. So that's going to be the square root of 2. For tangent, we flip it, but 1 over 1 is still just 1. Okay? Okay, now is your opportunity to practice. So I'd like you to pause the video right now. It's going to take a little bit of time. Remember, do the Pythagorean theorem first. After you've got the Pythagorean theorem, then you're going to find each one of these. Okay, so push pause on the video now, and then once you've worked out your answer, come back and push play. Okay, check your answers here. All right, how well did you do? Hopefully you got the second part, got a little bit tricky, but this is one that we kind of worked through just a little bit before, so hopefully not too bad, right? But you do want to check your answers on each one of these. Hopefully you did well on it. Let's give you some more practice on it though. So here are your problems. I want you to push pause on the video. After you've obtained the answer, come back and push play. Check your answers here. Okay, that second one got to be a little bit much, right? Because you can reduce this one. So remember, if you can ever reduce, you always want to be able to reduce. Okay, so make sure to do that. All right, hopefully you're feeling a little more confident now. Now, I'm gonna spice it up a little bit. Previously, on all of these, I've kind of provided the triangle for you, which made it really nice. This one, I don't provide the triangle for you. I just tell you that the tangent of theta is 1/2. And you've got to tell me all the other 5 ratios then. Well, it's not that bad. The only thing is this is going to take your artistic ability. It's your turn to create the triangle. Okay, so what I want you to do, and what I do on all of these, is I draw a triangle. Some random triangle. It doesn't really matter, and it doesn't have to be perfect. In fact, this one won't be, but that's okay. It'll be pretty close. All I know, and I always put just theta here, and if it's tangent, I know tangent is the opposite side divided by the adjacent side. So that means I know what this side is. This side is 1, and then the adjacent side here is 2. Well, if I know that, then I can quickly identify what my hypotenuse is by using the Pythagorean theorem, right? 1 squared plus 2 squared equals c squared. So 1 plus 4 equals c squared. So c is equal to the square root of 5. And now that I know that, I can find all the other 5 trigonometric ratios. Push pause on the video now. I'd like you to work those out. Once you've obtained those, come back and push play. Okay, check your answers. How did you do? Hopefully, not too bad. Hopefully you're getting some practice here with rationalizing the denominator. That can be a little bit tricky at times. Okay, now that we've got that, I want you to try these two. So these are going to take a little bit of work. And again, you've got to draw the triangle first. That always helps me so much. And we know that sine, we already know that that's the opposite over the hypotenuse. So you know 2 of those sides, you can use Pythagorean's theorem to plug it in. All right, so push pause on the video now. And then after you've obtained the answer, come back and push play. Okay, check your answers here. There's a lot to these, right? This is a big one. This isn't an easy lesson, not by any means. So anyway, hopefully you're getting some of those. All right, let's move on. Let's try that again. Same thing again. I'm going to push pause on. I want you to push pause on the video now. And then after you've obtained the answer, come back and push play. Check your answers. Okay, let's just talk about this one for a moment. This one, if you did this correctly, you ended up with 5 here. And let's just talk about this for a second. 2 times the square root of 6. When we're squaring that, we're going to go 2 times 2, And then we're going to go square root of 6 times square root of 6. So 2 times 2 is 4. Square root of 6 times square root of 6 is square root of 36, which is 6, right? So then we end up with 4 times 6, which is 24. Okay, hopefully you got that. That's just a little bit tricky. Just a challenging one I wanted to throw at you, see if you could get it. So, all right, now let's go back to my parasailing because as you know, I've got a fear of heights, and I'm not a big fan of going up really, really high, especially above water when there's creatures in there that I don't know about. So I wanted to find this one out. So we can use this one, and we can find out how far off the ocean we are by using our trigonometric ratios, specifically sine, right? So here's our this is like a triangle, right? I mean, if we look at this, this looks pretty close to a triangle right here. If I drew a line straight down, coming across, that would look like a triangle to me. Let's say that this rope that is attached to me, or a cable is attached to me, is 800 feet long. First of all, too long. Too long, I don't think I can handle that. But let's say for a second that this is what they have. The rope is 800 feet between the boat and myself. Okay, and it's at an angle of 25 degrees. Okay, now using that, I got a feeling I can calculate how far off the ocean I am. All right, so I'm just going to use what I know. So instead of sine theta, now I know it's going to be sine 25. Okay, theta was the measurement. A lot of times it's an unknown measurement. But now I know the measurement. The measurement is 25. So I'm going to use 25. So I'm going to go sine 25 is equal to the opposite divided by the hypotenuse. And hypotenuse in this case would be the rope, right? I mean, this is my hypotenuse. This is my longest side. And then the opposite side here would be the distance from me to the ocean. All right, so that would be my x. All right, so sine 25 is equal to x divided by 800. Now we're just going to solve this one for x. In order to get 800 from the bottom, it's x divided by 800, so the opposite of division is multiplication. I'm going to multiply both sides by 800. Now what I can do is I can just go 800 times sine 25, and that will give me what my value is. Now, and the value on that one is 338. Now, let's show you how to do that on your calculator. So I'm going to bring up my calculator here. All right, on this calculator here, here's your trig button. You're going to love this one. We're going to use this all the time. So trig, and then we go right here. That's sine, cosine, tangent, cosecant, secant, cotangent. So it's got all of these. Okay, so we're going to use the sine button. We already know what sine is. Sine is 25, and it needs to go 800 times that. So let me go back over here and type in 800 times. I hit enter, and it goes, congratulations, it's 800 times sine 25. And you're like, oh, thanks, that didn't help at all. So instead, this is giving me the exact answer. I just want it to round. So all we do is we hit Control, Enter, and that will give me my 338 feet. So this is 338 feet above the ground, which otherwise known as way too high. Way too high, wouldn't go on it. It's just too much, right? So for me, it's not doable. It's just too much. Okay, 338 feet, we got that in there. Okay, I want you to do this one. Okay, this is very similar to the one that we just did with the parasailing, only this one is a ladder, and we know how long the ladder is. It's 27.5 feet. Okay, we're trying to identify how tall this tree is. Okay, so push pause on the video now. I'd like you to work through this. Then once you have the answer, come back and let's check it, okay? Okay, check your answer. Hopefully you found out that the height of the tree was 15 feet tall, okay? Just check your math here to make sure that you're entering that in correctly. Hopefully your calculator's doing all the work for you, right? You don't want to do it yourself. All right, now that we have that, now this one isn't real life, but it's the same thing, right? I want you to think in your head, are you going to use sine, cosine, or tangent on this one? I'll give you a hint. This one, let's see, we know this angle. This is the opposite side, and this is hypotenuse, so that would be our sine. Okay, so push pause on the video now. After you've obtained the answer, come back and push play. Okay, this one got to be a little bit tricky, so let's go through this one in depth. All right, so we know that it's sine 46 equals 16 divided by x this time. Okay, when I look at this one, I start to freak out just a little bit. Now I've got my variable, my x, my unknown on the denominator. Okay, that's not a good sign. Well, it's really not that bad. Just like how we got rid of the 800 on the last problem, we multiplied both sides by 800. That's the same way that we can pull x out of the denominator. So I'm going to multiply both sides by x. All right. When I do that, I end up with x times sine 46 is equal to 16. Well, if I want to get x all by itself, the opposite of multiplication is division. So now I divide both sides by sine 46. Okay, so x is equal to 16 divided by sine 46. And you're going to type that into your calculator, just like you see it, right? Do the 16 divided by sine 46. You end up with 22.2. It did ask you to round it to the nearest tenth. All right, now you've got a couple here we can try to practice on a little bit. So I'd like you to push pause on the video now, and I'd like you to work through these. Once you've obtained your answer, come back and push play. Okay, check your answers here. Hopefully this is, you're getting a little bit of practice here and you're starting to kind of get the flow of it just a little bit. But just check. If you made an error, that's okay. Just go in and identify where your error is, okay? All right, I want you to get some more practice. So now's an opportunity. Let's push pause on the video. I'd like you to work through this one. And then come back and then we'll check your answers. Check your answers here. All right. This one, we're going to walk through it together, all right? But if you've got this, if you've got these down, the rest of this isn't going to be so bad. All right, let's go through this one. Two inspectors are walking toward a tower that's 250 feet tall. The inspectors are exactly 50 feet apart, and the closest inspector has an angle of elevation of 26 degrees. What is the value of x? In other words, what is the angle of this second inspector? That's a little hard considering I don't really know what this is, right? I mean, if I knew what this whole entire amount was, well, then I could use tangent, right? I've got the opposite side divided by the adjacent side, and I can find it. But the problem is I don't know that. Well, it's really not that bad because using this information from this first inspector, I can find out what this side length is, right? I mean, if this were x, let's call it, well, we have an x already, so I can't call it x. Let's call it y. Excuse me. All right. For this y, I can use this and I can go, okay, this is tangent, right? Opposite divided by the adjacent. So tangent 26 is equal to 250 divided by y. Okay, and we can solve that one. That's just like the one that we were just doing. All right, right? I multiply both sides by y, and I end up dividing both sides by tangent 26. So I end up with this 250 divided by tangent 26. And I get this really long number, and don't round it until the very end. Okay, now that I have that, I know this is basically 512 feet. So y is 512 feet. So the distance here on all of this is my y, right? 512.57596, plus this 50 portion. And that will help me find this one. So I'm going to do the exact same thing here. Trig ratio, right? Tan x, I don't know what this is, but I do know that it's opposite divided by adjacent. So 250 divided by this y, which is this big long number, plus 50. And now all I'm going to do is I figure out what that number is. Here we go. Okay, now here it gets a little bit tricky because we're trying to find out what this angle is. So we're going to go back to the calculator. Okay, so I'll show you what the answer is here. It's 23.96, but let's go back to the calculator and show you how I found that. Okay, let's go back here. And I'm looking for the tangent x, and this is the unknown, is equal to 0.44384. Okay, so all I'm going to do is I'm going to go right here to this trig ratio, and look at this. Instead of tangent, I can look for the inverse, right? And this is going to be 0.444384. And I hit enter, and there we go. That's what it is. So this will help you easily calculate it. It is a little bit different, right? This is like the inverse there. We've used that before. Okay, we've kind of gone through all of those. There you go. All right, now on this next one here, it's very, very similar to the first one that we just did. I just want to get a little bit more practice on this one, okay? So again, I can use this information to find out how long this one is. Okay, so let's do that first. We've got y is what we're looking for, and this will be the tangent 30. We know what this degree is equal to 75, so the opposite divided by the adjacent. 175 divided by y, 175. All right, so I multiply both sides by y, then I divide both sides by tangent 30. Of course, I'm going a little bit quick on this. If you need to slow it down, you can. All right, and I come up with this number. Now I'm going to take this number. Now I know how long this is, right? 303.10 plus 70 feet. So now I go tangent x is equal to 175 divided by this big long number, 103.10889 plus 70. And I'm plugging that into my calculator. And I can quickly obtain the answer. All right, this is a little bit of a long lesson, so I apologize for the length, but as long as you're working through it and you're pausing the video, hopefully you're finding some success there. Please let me know if you have any questions. I'll create some additional videos as well to post. that are on specific examples of specific problems.